Looking on this matrix, this web vitals, we have here two core web vitals. One is the LCP, which we have encountered a few times, and one is the CLS. And in this lesson, I want to reduce the CLS, but first I want to show you what it actually is. We are talking about layout shift and cumulative because few elements can cause layout shift. So let's look at it. So I want to show it using mobile device, and I'm using here slow network, slow LG. And now let's look. Let's refresh. And you see that, okay, let's look at it again. But if you look at this text, you see that it appears somewhere here and then it is pushed down because it takes time for this picture to appear, and the browser does not know the sizes of this picture, so he cannot reserve the space and put the text behind it. So let's do it again. Look at this text. It will appear here and then it will be pushed down. Okay, so refresh. So the text appear here and then he's pushed down. And this is not a good. Also here it was pushed, this one. Let's refresh again. You see that this will be also pushed down even further. Okay, and this is not a good UI experience because the user maybe start reading here and it's pushed down. Okay, so I'm showing you this on this web page. If you want to read more about it, you can look at these articles from web.dev, which is excellent source. And you will see here a definition. Cumulative layout shift is a stable core web vital metric. It's important use a generic metric for measuring visual stability because it helps quantify how often user experience unexpected layout shift. Okay, I will not get into how this is a big article. I will not get into how to compute it, but you saw that there is layout shift. This was layout shifted and this also was layout shifted. And this is part of the core web vitals of the Lighthouse score. So this is the motivation. And also we got an diagnostic about the size of the images. Okay, if we would have give the images size, width and height, then this will not be happen because the browser would know to handle it. And we see that the problem is with the dog, right? Maybe also with the other. So we will start with the dog. And we need to provide the width and the height, but there is an issue here because with the dog, the size is changing. So we cannot provide width and height, but we can provide the aspect ratio. Aspect ratio, if we will look, aspect ratio, HTML, it's a CSS property that you can define the width to height ratio. Okay, and we saw that at least for here we have preserved the aspect ratio. Okay, so let's do the following. Let's put here style aspect ratio, and let's divide this by this. I think it was 2.3, but let's do it again. Calculator 1640 divided by 703, and this is 2.33. Okay, so 2.33. Let's invoke it again. Okay, let's refresh. Okay, you see now that the text here is not changing. Okay, this is because the aspect ratio is known. But it did change for this and for this. So we need also to add the aspect ratio. So we do need to also add the aspect ratio to the other dog here. And we need to add it also to the other picture. So let's compute the aspect ratio of the other images. So 7/3 delays, 7/3, 2.33. And the service is the same. So we can use the style, image style. So let's add to the image, and let's add a style. Aspect ratio 233. And let's remove it from here. Okay. Okay, it does not appear. Go live. Network, refresh. Okay, you see, nothing is moving. I think I need also here this we have something here. Okay, so what is it? We give up. Let's first see if what's the score, and then see if we need to handle it. So git add -a, git commit -m, aspect ratio for all images. Git push. Okay, and speed inside here. Oh, for some reason, don't understand why.